Same as yesterday's.
It is?
That's the yesterday's on your target.
Oh.
Alright, so input output table, please open. Open says me. So on an input output table, which do you think is the input, X or Y?
Why?
Why is that?
And I asked which one's the input.
Oh, X, sorry.
Okay. Alright, the input is X and the output is Y. The input is X and the output is Y. So we can write an input output two ways. We can write it horizontal and vertical. In a vertical table, X is on the left. Yes. Just a second. And Y on the right. Alright, so in a vertical table, X is on the left, Y is on the right. And in a horizontal, which way is horizontal?
Landscape.
Landscape, and which way is vertical?
Up and down.
Yes. Alright, so in a horizontal, X is on top, so where would Y be?
Bottom.
Fantastic.
Hate horizontals.
It's a weird thing to hate. Of all the things in the world to hate.
Not really. We have to do
Oh,
practice.
for a second I was like, what did she say?
Okay, so what we're going to do is we are going to take our set of ordered pairs and we're going to turn it into a table. So, are you guys ready for this?
Not really.
Not really? Why?
I mean, I'm ready to do this, but I'm not physically ready.
what?
Is it fun?
It is. Mapping is. I like mapping diagrams. Tables are, I mean, you know, it's just a table. We just put stuff in there. But on a mapping, we get to draw things.
Right.
Yeah.
And why?
Okay. Alright, so all you do in this is you take your X and your Y and you put them together. So X is 5, Y is 2, X is 3, Y is 7, X is 6, Y is 4, X is negative 5, Y is 9. Boom, you're done. That's it. That's all you do on a table. So if I draw a horizontal one, can you guys put it in order from there?
Yes.
Or do you need me?
I don't know, because I didn't even look at you when you were doing that test. I got Huh? Oh, we did this last year, so I think I got it.
What did you guys write first in the horizontal?
Nothing yet.
5 on the top.
5 on the top, 2 on the bottom. Look, super easy. And then,
3 on the top. 7
and then,
6 and 4.
and then, besides these two over here, can anybody else answer?
Negative 5 and 9.
Look at us go. Easy peasy. That's it. I know. It's boring. It's easy.
Got us there.
Mapping is fun. And graphing.
Oh, I hate
Huh?
graphs.
Yeah, we're going to do graphing now.
Somebody sit in chair.
Oh.
Well, apparently I can't do it.
Well, the
Oh,
chairs,
broke it.
yeah.
Who broke
Yeah,
it?
that's pretty cool.
So it's just the bottom of my old teacher chair.
Yeah,
It's okay.
Graphing, sweet children. Please open up the graphing tab. All right. It says if someone does want to sit in the broken chair, you may.
Okay.
Not you. You've already sat in there. Okay.
So then okay, this one I don't like.
All right. So it says the x coordinate. What does the x coordinate tell you to do when you're graphing?
So put it on the bottom.
When you're graphing,
Oh my gosh. It's like leaning back and forth.
be very careful,
This is
please.
really sad.
Be careful. All right. So the x coordinate tells us to move left or right. Both guys. But I do appreciate you answering like it was a question. So what does the y coordinate tell us to do?
Up and No.
Yes.
I remember this.
I hope
You
so.
should because it was like first grade.
Whoa. It wasn't a question. Thanks for waking up and joining us. All right, so which comes first, X or Y when we're plotting? X comes first, always. Okay, so we are going to plot these bad boys up there.
Yes.
Okay? So do you guys want to do it together or can you do it without me? Together? Okay, we can do it together. Let me know when you're ready. Finish writing. Do what you got to do.
Oh, I understand.
Prepare yourself.
Oh no, I know
Why is my life not together right
All right, so to plot 5-2, are we going to go right 2 or left 2?
now. Right.
Why?
Because it's not negative.
Because it's positive. So we go right 1, 2, 3, 4, 5, and then up 2. And then we label our dot.
4, 5.
All right, how would we plot 3, 7?
Right 3 up 7. Yeah. 1, 2, 3. Put on. 1, 2, 3. 1, 2, 3.
And then for 6, 4, ooh, I'm not going to plot that because that's going to be on top of the others. So I'm going to pretend like that says -6
Okay.
and -4. We're going to go crazy. So let's go left 6, 1, 2, 3, 4, 5, 6, and then down 1, 2, 3, 4. Do you forget where you are when you're counting these on the grid? Because sometimes I do a lot. It starts crossing for me.
That's why I have to count out loud.
All right, and then -5, 9, we would go where?
To the left 5.
1, 2, 3, 4, 5, and up. 1, 2, 3, 4, 5, 6, 7, 8, 9.
2, 3, 4, 5.
At least we didn't have to draw our own graph, and I found these to put it in there. It's exciting.
What was this, -5, 9?
Yes. And make sure you label your points.
I just hate when I have to label the actual coordinates. I meant the
Oh my
quadrant.
gosh, I went to one back.
1, 2, 3, 4.
Yeah,
counterclockwise.
but sometimes it doesn't happen that way.
I just want
All right. Don't. Please be careful. Please be very careful. All right. So, are we ready for the mapping diagram? Or do we need another minute?
I'm ready.
I'm ready.
Okay, Tater.
This is really awesome. No. Thank you. Yeah, she said right on. Now you do her directions.
And then when I walk around, I'll get it and bring it over here to you. Over here to her. Okay.
Wow.
Since we're passing notes, I'll read it out loud and put it on the video.
What note?
Away right now. All right, mapping. Are you ready? Mapping, mapping, mapping. Please open mapping. We don't have words because this is difficult to describe. But in your input, I would like you to please list your X values up here from least to greatest. So tell me what comes first.
Probably
-5.
And then?
I thought it was -6.
And then?
5.
Guys, on our input, we're just listing our X's. We're listing these. Yeah, it's okay. I did. Thank you for listening. But we're just going to list these guys right here for the moment. All right, so -5, then 3. Remember, we're only listing our X's in the input column. What comes next?
5 and 6.
Okay, now I would like you to please do the same thing in the output column. Least to greatest.
2 and 4 and 7 and 9. Then why do you draw the lines for it? It's already there.
I'm going to show you. All right, so get a different colored marker or color pencil, some kind of something. You can use my markers.
I couldn't use your mark. Yes, I did. I didn't ask.
4. Oh, okay.
All right, so a mapping diagram means that you draw an arrow and map your X coordinate to your Y coordinate. So what is our Y coordinate for -5? No, up here. What is it? 9. So from -5, you draw an arrow down to 9.
Do you have to put the little? That's what
Yes. Yeah. Yeah.
Do you have to put the line for?
Yes. And then for 3, what are we going to match that with? And then for 5, what will we match him with? And then 6.
How'd you mess up, Megan?
And that's it. That's all you do for mapping.
Why does yours look neat and mine doesn't? Right.
I don't know, guys. I think it's from 30 years of practicing handwriting. It's probably what it is.
You're not even 30. Yes, you are. You don't look 30.
Yeah. I was about to say you're 22, but you're not Brett Davis. So.
All right, so DIX, domain, inputs, X coordinate. Do we know what the domain is?
Yes.
What is it?
X-axis.
The X-axis. It's also the X input values, right?
Yes.
So the domain of a relation is the set of all inputs or X coordinates. So using that same phrasing, how would we word Y or the range?
The range is a set of output.
Yes, and we should put the relation in there. That was very good teamwork. The range of a relation is the set of all outputs or Y coordinates. And how do we write a set? What do we have to put around sets?
There's S and then the double.
And those are called
brackets.
brackets. Yes. So, if you're out of room like me, I would like you to get a sticky note to do this next part. If you're not out of room, then you can write it on the bottom.
I think we should slow down.
Do we need a lot of room?
No, not a lot.
Oh, I have. Oh, I was about to say I have really pretty sticky notes.
Very much. Okay, so I'm going to show you how we write our domain and range, and I'm going to put mine up here for the moment. Are you guys ready, or do you need another minute?
Just like 3
Okay. In range of this relation that I'm going to write down. So please write these coordinates down.
So go ahead and go all the way again so I can see what that means. These things are hard to write.
Because every time I do it how you say it, it still don't look right.
I learned the pattern. They look awkward sometimes though when I do them fast.
All right, so we're going to write our domain. And what is the domain? The X values. So if you get confused on which one's X and which one's Y, just go through and label all the X's. X, 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 X. So what does the other have to be? Look at us go. So I want you to list them in order from least to greatest. So what's the smallest X value up there?
Negative 10.
Negative 10. And then?
Negative 6.
And then?
Negative 2.
Negative 4. And then?
2. Yeah, I was looking at it.
Okay, so now that we've done the X together, do the range. Do the Y.
From least to greatest?
Yes. Does everybody's look like mine? That's all you have to do.
For what?
And that's it for relations.
When do we do that?
If I say list the domain and range.
Okay.
Pardon? Okay. Yeah.
I literally went to go call my notes last night, and then I saw that post, and I got really excited. Because it was like 10 at night, and it was the only.
That was yesterday's.
Oh my gosh,
Well.
I just.
Function.
I can determine if a relation is a function
Or not.
Bless it.
or not. Okay, so all functions are relations, but not all relations are functions. So today we are going to determine what makes a function a function.
You're kind of stressing me out.
Good.
Not good. I feel like I've been practicing for about 3 hours, and I'm very about to try to press clock my finger. It's so good.
Hey, how are you?
Did you think it was ironic that it's the 20th and this is the 20th page?
Yes, sir. It was nice meeting with Mike.
I didn't even notice. That makes my soul happy. Thanks for telling me.
That seemed really.
Did I notice yesterday?
No.
I don't remember.
You never said anything about it yesterday.
Who knows? Thank you.
Oh my gosh, I can't get my life together. I don't
Alright,
think I
so-
said it yesterday.
I need you to breathe.
Well, you're not letting me.
It's called WITE. That's how you guys spell white. That's wit. Or what would that be? Wit.
A function. Let's write the definition down. It says a function
A function.
is a relation where every input has exactly one output. Every input has exactly one output. What do you think that means?
I don't know. Doesn't every input have an output?
It only has one.
Keep
Y.
running me.
It only has one X.
Each X can only have what?
One Y?
One Y. So if I wrote down, for example, if I wrote down, all right, so I have two X's here. Well, let me write it like this. Don't write this, just watch. All right, do I have the same X value there?
Yes.
Do they have different outputs?
Yes.
That's not possible.
Oh,
So your X's cannot repeat. You have to have different X's. Hey, I'm teaching. Stop. All right, one more time. What?
I thought you said it can only have one Y.
It can. So what I'm saying is each input, if I put this into a problem, okay? If I put 3 into a problem, think about when we had F at N, or we had what? M at N equals 6N plus 10, something like that?
Yeah.
And I plug in 3. I can't get out both 4 and 9, can I? So if you plug it into an equation, you can't get out 2 different answers. That's what it's saying to
okay,
you.
That makes sense.
Your Y's can repeat, your X's cannot.
Okay. That
All right, so characteristics. Did any of you do the vertical line test last year?
No.
Vertical line test. Okay. Well, when you have a graph, okay, and you draw a vertical line through it, it can only hit it once. That's what makes a function. Hey, we're doing a lesson. Thanks, Tater. All right, so characteristic says if you can draw a vertical line through the graph and it hits the graph more than once, it is not a function. And don't worry if you don't completely understand what that is going to look like. We're going to do some examples and non-examples to show you. And if it fails it, so if it hits it twice or 3 times, we say a certain thing. We say the relation fails the vertical line, Blair, test. So I think I want to do a non-example first. I want to do a non-example of a graph when y'all finish writing. Mix it up a little bit. Are you about to sneeze? Or are you just thinking?
Oh.
Okay. Alright, so please, under non-example, draw for me your X and Y axes. And I'm going to draw, this is going to be my graph. Yes, please. Alright, so after you draw your graph, I want you to please get a colored marker, pencil, prick your finger, something. Get a different color. Okay, so vertical line means you literally take your marker. I'm gonna use green. And you draw a vertical line through it like that. Now, how many times does my green line hit that graph?
Twice.
Twice. Once right here and once right here. That is not a function. It failed the vertical line test. I know. It's still a relation though, so it's still somebody. Now, if we wanted to draw an example of what a graph would look like, let's come over here and draw our axes. And then I'm going to draw my graph in orange again. Alright, so once you have the graph that looks like mine, draw a vertical line through it. Get a different color, draw a vertical line through them. How many times does it hit him?
1.
So that's a function. Ta-da! It passed the vertical line test. Alright, so now I'm going to do a mapping non-example. because I want to show you what it looks like in a mapping where each input doesn't have one output. So that means that your x's cannot repeat. You cannot have an x that has two outputs. So if I drew a line from 3 to 5 and 3 to 1, that means that that x has two answers, and that's not possible. We can't plug in x and get two different answers out. And if I drew a line on 4 from -2 and to 5, that also has two answers, and it can't be possible. What do you think it would look like on the other side?
Even though
With one answer.
A little more detail. Tell me again. Like, say it a little more. What has to only have one answer?
X.
Has to have,
One answer.
yes. Okay, so I'll let y'all finish. I'm getting excited. I love functions.
I like this better than.
The LTF.
Yeah.
Don't worry, we're going back to that.
The big packet. No.
It gets easier. I swear it does. It really does.
It's not that it's not easy. It's just
We got another packet?
it's not fun. Like it's not like this makes me happy.
How about if we color it together?
Let's do that.
Okay, we'll color it.
Wait, we have another packet?
hmm
Like,
After this.
It's just so many questions.
Yeah, we're going to go back and forth. Don't worry.
pray for me.
Let's go back.
Pray.
Let's stay forward and not.
I failed that test. 'Cause,
All right, so draw a little baby mapping. We're going to call him X and we're going to call him Y. And I'm going to write 1, 5, 7, 3, 6, 10. That is a function because each input has only one output. And the last thing, and then you get your homework for tonight.
I think I should have told us we need to leave room, guys.
why does the 1 have to go to the 10 and 5 go to 3?
Because I wanted it that way. It doesn't have to. We just picked that as the example. Yeah. I just made it up.
I barely have anything.
Put it on a sticky or right below it.
Now I'm trying to fit it in.
Okay. All right, so what do you notice about this problem? About the example that I just put up there?
All Y's are
For
2.
the Y.
All the Y's are the same. Now, we said that each input can only have one output. Did we say anything about the output? All right, so X's cannot repeat, but Y's can. The X can never repeat. You might want to write that down somewhere. X can never repeat. X can never repeat.
X never.
X can never repeat. How about you sit up in a desk like a normal human so when I walk through I don't trip on you and die? Kalia, will you reach up and hit pause for me, please? Sure.